Hello, everybody. This is Mr. Kusaj, and we're back with lesson 6-5. Don't forget to put the date next to 6-5. This lesson is called linear optimization. Okay. I guess there's lines involved and optimizing involved, making it the most it can be, the greatest it can be. Okay, anyway, we'll get into it as we go along. Linear programming. What is linear programming? Linear programming is, I tried to make it as concise as possible. This is the best I can do. You're going to find an XY, a point that will give the maximum, if that's what you're looking for, or the minimum value for an objective function. So we're going to give you a function, and you're going to find the point in that function that gives you the greatest or the least value, depending on what you're looking for. But you're going to be given certain constraints. Okay? So let's get into an example. Right? So now this function looks a little different because we don't want just f of x, we want f of xy. So both x and y are in our function. Okay? So what I'm asking you is, what is the greatest x or y? What's the x and y that gives you the greatest value? So you might think, well, obviously the biggest number is possible. But no, wait. We have constraints. So we want to know, right? We want to know the maximum and minimum for this, but these are the constraints. So the constraints are these lines, right? So if you look at the constraints, this is some line, this is some line, this is another line, and another line. So if we graph these lines, okay, we'll see that it forms a closed shape. So in that closed shape, what point in that closed shape will give the greatest value and the least value to this function up here? Okay? Sounds a little confusing, but once we graph these constraints, it'll become a little clearer. Okay? So, can you graph a line? Do you know what to do if your equation comes in this form? Well, you quickly turn it into a y equals mx plus b form, right? So from here to here to here, right? I can graph this, right? You can graph this. That's the slope. That's where you start from, right? How about this one? Let's change that to y equals mx plus b. And these are easy, right? This is just the axes. Okay, so the first thing we're going to do in the steps is to graph the constraints. In fact, let me write down all the steps first. So we're going to graph the constraints. That's these 4 equations. Find the coordinates of each vertex. Okay, vertex is a corner. Okay, so figure out what the point is at each corner. And then evaluate the original function. Evaluate the original function at each vertex. Okay, sounds a little confusing, but once you see this in action, it's something that you've done before. You have graphed lines before, so let's do that again. So here is all the constraints graphed. So let me go back and forth here. One of them was y is less than or equal to negative 2/3 x plus 4. Okay, so I start at 4. There it is. I start at 4. This is how I graph it. I start at 4, and then I go down 2 over 3, right? Down 2 over 3. Down 2 over 3. So it must be this line. So I got 1. I did this one, right? Now let me do this one. This one starts at 8 and goes down 2 over 1. So starts at 8, down 2 over 1, down 2 over 1, and there's that line. So I got 2 of them. Now these are the easy ones because these are the axes, right? So x is greater or equal to 0. So x equals 0 is this line, the axes, greater than or equal to 0, right? And this is y equals 0, this axis, right? So greater than, so you shade in the center there because we want, if you go back, we want y to be less than this line, y is less than this line, and then greater than this and greater than this. So in other words, this is the shaded area. So what did I just do? All I did was graph the constraints. Okay, graph the constraints. Those lines will make a shape. Now notice in this shape, we have 1, 2, 3, 4 corners. I would like to know what those corners are, because one of those corners, when I plug it in, will give me a maximum value. I suspect it's this one or this one. It can't be this one. This is way low. And one of them will give me the lowest value. I suspect it's either this one or this one. So first, let's figure out what these corners are. I did it for you. So the vertices are, look, this is what? This is 0, 1, 2, 3, 4, 0, 4. This is 3, 2, there it is. This is 0, 0, there it is. And this is 4, 0, there it is. So these are my vertices. Now that I have my vertices, how did we get them, right? We graphed all the lines and saw the corners. Okay, so now that I got my corners, my vertices, I plug each one of them in one at a time to see what value they give me. This is the original function, right? This is what we started with. So the x and y, I'm going to plug in these x's and y's one at a time here. Let's do the first one, 0, 4. What is f of 0, 4, right? If I plug in 0, 4 in here, what do I get? There's x, there's y. Oh, I get 8. So this corner gives me 8. Let's do the next corner. Let's do 3, 2. What is that corner going to give me? Well, I plug in 3, 2, and I get 13. Wow, that's even bigger, right? Let's do all of them. F of 4 is 0. Plug it in, I get 12. F of 0 is 0. Plug it in, I get 0. So we can plainly see that this point, where is it? 3, 2 gives us the highest value. That's the maximum. The maximum happens at 3, 2. And this point, 0, 0, gives us the lowest. So that's the minimum. That's what I wrote down. Maximum happens at 3, 2. Minimum happens at 0, 0. That's it. We are done. We figured out the maximum and minimum for that function. Okay? One more time. One more example. Here we go. So the question is, find the maximum and minimum for this function, right? So just put in the biggest numbers. No. We have constraints. So here are the constraints. Let me reveal the constraints to you. What are the constraints going to be? The constraints are going to be lines, equations of lines. You're going to graph them and see the figure with the corners, right? So here are the constraints. That one. Wow, that's a lot of them. Right? Let me pull it up. That's a lot of them. Okay? So let's change. This is easy, right? X is less than or equal to 10. That's easy. These are easy also. We just did this. So we really have just 3 lines. So let me switch these to y equals mx plus b form, because it's easier. For me, it's easier to grade when they're y equals mx plus b form. Right? So this, with algebra, becomes this. Right? And this, with algebra, becomes this. So I have to graph this, and this, with algebra, becomes this. So I have to graph this, and this. Okay? All I'm doing is graphing a line. If you think about it, all I'm doing is graphing a line. Once you graph all of them, though, you'll get this. Right? So I don't want to get into details, but in Precalculus, you should know how to graph a line. So all I did was graph 1, 2, 3, 4, and then the axes. These are just the axes, right? So I have 4 lines, 1, 2, 3, 4, and then the axes, right? So then, now that I see my corners, I go get the points. Now notice, this one is easy, right? 0, 5, 5, 0, 10, 0. And this one, if you look carefully, this one is easy too, 3, 8. Okay? But this one doesn't fall on a corner. It's 10 something, but I don't know what it is. And I'm going to need it, right? Because I'm going to plug in all of them. How can I plug this in if I don't know what the y coordinate is? Right? So what do you do when you don't know the full coordinate here? Well, you have your x. You know it's 10 across. You just don't know how high up, right? It's a little bit past 3. 1, 2, 3. It's a little bit past 3. Let's plug in this x and see what y it gives us. So we go back to this line. We go back to this line and plug into 10 and see what it gives us. So that's what I did first. Right? I'm looking for that coordinate. So before I start plugging in the corners, I need to find out what that corner is. 10 what? Well, I'm going to plug in the 10 into the equation that gave me the line. Right? Plug in the 10, and what do I get? 3.3. So this corner is 10, comma, 3.3. Right? So it's a decimal. We didn't have a decimal before, but so what? We have calculators. So my point is 10, 3.3. That point is 10, 3.3. Now I'm ready to plug in all the points. Right? So I'm going to evaluate this original function with each corner. You can start anywhere you want. You just have to do all of them. So what did I do first? I did f of 0, 5. I started over here. And it gave me 15. Then I went to f of 3, 8. And it gave me 30. Then I went to f of 10, 3.3. And it gave me 29.9. Almost 30, but it is less than 30. And then I went to, let me make sure you see this. All right, so all I'm doing is plugging each corner. I'm going around this way. So f of 10, 0 gave me 20. F of 5, 0 gave me 10. So now I look back and see what is the maximum and minimum. The highest one was at 3, 8. That gave me 30. That was the maximum. It gave me the biggest answer. The minimum, the smallest answer, was given to me by 5, 0. Right? So that's what I wrote down. The maximum happens at 3, 8. Okay. The value is 30, but that's not the question. The question is, where do I get the maximum? Where? Which coordinates give me? Right? Now I found out this coordinate gives me the maximum. Okay? Where does the minimum happen? Well, it could happen, I guess, here or here, but I found out it actually happens here. Okay? So the minimum happens at 5, 0. Okay? That's it. Let me leave you with one try problem. If you don't know anything that's going on, at the very least, graph the constraints, 1, 2, 3, 4, in one paper, in one graph, in one place, okay? And then we'll talk about what to do next. Try to do the whole thing. We'll do this in class, but at the very least, graph these 4 lines, okay? See you in class. Bye-bye.